Understanding the IDS/IPS deployment scenario. Welcome. Let's explore a critical security deployment scenario in Google Cloud Platform. A social media company needs to implement an intrusion detection and prevention system, IDS/IPS, as part of their network security strategy. The key challenge here is understanding how traffic flows in a hub-and-spoke network architecture. We have a DMZ VPC acting as the security hub, and 3 other VPCs serving as spokes. The requirement states that all internet-bound traffic from the 3 spoke VPCs must flow through the IDS/IPS appliance. This is a common pattern in enterprise deployments where you want centralized security inspection. Think of it like having a security checkpoint that all outbound traffic must pass through before reaching the internet. Analyzing the network architecture. Let me show you what this network architecture looks like visually. We have 4 VPCs total. 1 DMZ VPC that will host our IDS/IPS appliance, and 3 spoke VPCs that contain our workloads. The critical requirement is that traffic from the spoke VPCs must be routed through the IDS/IPS before going to the internet. This creates what we call a security choke point, a single point where all traffic can be inspected. Notice how the DMZ VPC acts as a hub. It's connected to all 3 spoke VPCs and also has the internet gateway. This hub and spoke topology is fundamental to understanding which answer options are correct. Option 1. Custom route in DMZ VPC. Let's examine the first option. Create a custom route in the DMZ VPC for internet-bound traffic that points to the IDS/IPS network interface. This option is incorrect, and here's why. The DMZ VPC already has internet connectivity. Creating a route within the DMZ VPC doesn't help us achieve our goal of routing traffic from the spoke VPCs through the IDS/IPS. Think about it. If we're already in the DMZ VPC, we're already at the security perimeter. The challenge is getting traffic from the other VPCs to pass through our IDS/IPS appliance. Option 2. 3 network interfaces. The second option suggests create the IDS/IPS instance with 3 network interfaces, with 1 interface in each of the 3 VPCs in the network. This is also incorrect. While GCP does support multiple network interfaces on a single VM, this approach has several problems. First, it doesn't include an interface in the DMZ VPC where internet connectivity exists. Second, even with interfaces in each spoke VPC, we'd still need routing to direct traffic through the IDS/IPS. This option misunderstands the hub and spoke model. We don't need the IDS/IPS to be directly present in each spoke VPC. We need traffic to flow through it centrally. Option 3. Custom routes in spoke VPCs. Option 3 states, create a custom route in each VPC except in the DMZ VPC for internet-bound traffic that points to the IDS/IPS network interface. This is correct. This is exactly what we need. By creating custom routes in each of the 3 spoke VPCs, we're telling them, for any traffic destined for the internet, 0.0.0.0/0, send it to the IDS/IPS network interface in the DMZ VPC. This implements the security requirement perfectly. All internet-bound traffic from the spokes will be forced through our security appliance before reaching the internet. Option 4. 4 network interfaces. The fourth option proposes create the IDS/IPS instance with 4 network interfaces, with 1 interface per VPC in the network. This is also correct. This is actually the most robust solution. By having an interface in each VPC, including the DMZ, the IDS/IPS can 1. Receive traffic from each spoke VPC through its dedicated interface. 2. Forward approved traffic to the internet through its DMZ interface. 3. Maintain network segmentation between VPCs. This approach provides better traffic visibility and control compared to routing everything through a single interface. Option 5. Deleting default routes. The final option suggests delete the default route and create a custom route in each VPC except in the DMZ VPC for internet-bound traffic that points to the IDS/IPS network interface. This is also correct. This is essentially a more explicit version of option 3. By deleting the default internet route, if one exists, and replacing it with a route pointing to the IDS/IPS, we ensure all internet traffic goes through our security appliance. This is a common practice in secure environments. Remove any direct internet paths and force everything through security inspection points. Setting up the network, Part 1. Now let me show you the actual gcloud commands to build this infrastructure. We'll start by creating our 4 VPCs with appropriate subnets. The first command creates a VPC network. The subnet mode equals custom means we'll define our own subnets rather than letting Google create them automatically. The BGP routing mode equals regional keeps route advertisements within our region. Next, we create subnets within each VPC. The range parameter defines the IP address space. Notice how each VPC gets its own RFC 1918 address space. DMZ uses 10.1.0.0/24, while spokes use 10.10.0.0/24, 10.20.0.0/24, and 10.30.0.0/24. This prevents IP conflicts and makes routing clearer. VPC peering configuration. VPC peering creates a network connection between two VPCs, allowing them to communicate using internal IP addresses. Let me explain each part of these commands. The gcloud compute networks peerings create command establishes the peering. The network flag specifies which VPC we're configuring from, while peer network specifies which VPC we're connecting to. The export custom routes and import custom routes flags are crucial. They allow our custom routes, like the ones pointing to the IDS/IPS, to be shared between peered VPCs. Without these flags, only subnet routes would be exchanged, and our security routing wouldn't work. Remember, VPC peering must be configured from both sides. That's why we create reciprocal connections. Deploying the IDS/IPS instance. This is the most complex command, creating our IDS/IPS instance with multiple network interfaces. Let me break down each parameter. Machine type equals N2 standard -8 gives us 8 vCPUs and 32 GB RAM for processing network traffic. Can-IP forward is essential. It allows the instance to route packets not destined for itself. We define 4 network interface parameters, one for each VPC. Each specifies the network, subnet, and a static private IP. The order matters. NIC 0, ENS 4, connects to DMZ. NIC 1 to 3, ENS 5 to 7, connect to spokes. The startup script enables IP forwarding in the kernel and sets up basic NAT rules using IP tables. In production, you'd install your actual IDS/IPS software here. Configuring routing. Here's where we implement the core security requirement. First, we delete any existing default routes that might allow direct internet access. The gcloud compute routes create command builds our security routes. Destination range equals 0.0.0.0/0 means all internet destinations. Next hop instance points to our IDS/IPS, forcing traffic through it. Priority equals 100 gives these routes high priority. Lower numbers equals higher priority. This ensures they override any other routes. Finally, we create CloudNAT for the DMZ VPC. This allows the IDS/IPS to reach the internet. The router is required for NAT, and NAT all subnet IP ranges enables NAT for all subnets in the VPC. Firewall configuration. Firewall rules control which traffic is allowed. Let me explain each rule's purpose and parameters. The first rule allows spoke VPCs to send traffic to the IDS/IPS. Source ranges defines which IPs can send traffic. Target tags equals IDS IPS applies this rule only to instances with that tag. Direction equals egress rules control outbound traffic. We need one allowing the IDS/IPS to reach the internet. The loop creates internal communication rules for each spoke. Allow equals TCP, UDP, ICMP permits common protocols. This lets instances within each spoke communicate. The SSH rule, port 22, enables management access. In production, you'd restrict source ranges to your admin IPs. The 35.235.240.0/20 range is Google's IAP, Identity Aware Proxy, for secure access. Command Reference Guide. Let me give you a quick reference for the key gcloud parameters we used throughout this deployment. Understanding these will help you customize the solution for your environment. Network commands use gcloud compute networks for VPCs and gcloud compute networks subnets for subnets. Routes use gcloud compute routes, and they're crucial for traffic steering. The instance creation is the most complex, with multiple network interfaces defined inline. Each network interface parameter creates a new NIC in order, NIC 0, NIC 1, etc. Firewall rules have direction. Ingress is default, sources, destinations, and targets. The target tags parameter is powerful. It applies rules only to instances with matching tags, avoiding overly broad permissions. Summary and key takeaways. Let's wrap up with the key points. In this scenario, 3 options were correct. 1. Creating custom routes in spoke VPCs pointing to the IDS/IPS. 2. Deploying the IDS/IPS with 4 network interfaces. 3. Deleting default routes and replacing them with IDS/IPS routes. The common thread? All internet traffic from spoke VPCs must flow through the IDS/IPS. This creates a centralized security inspection point, a fundamental pattern in enterprise cloud security architectures.